Oh, and is anyone speaking? Is anyone speaking? What did you say?
So guys, we are starting now, okay?
Hi, in this video, we're going to review the control structures we've learned so far and see how they can be put together to solve complicated Tracy problems. We've learned many control structures that help us reduce, reuse, and recycle our code. We can use for loops, if-else statements, and while loops to write more effective code. We've also learned some ways to write more sophisticated code by using functions, parameters, and variables. All of these components can be used in conjunction with one another to allow us to write concise programs that solve complex problems. Here's one last new Tracy command that can be helpful when writing complex programs. The clear command can be used to wipe the screen clean of any markings that Tracy has left so far. Using this command will not alter Tracy's direction or position. It will simply remove all the trails she has left prior to the command being called. Let's look at our last Tracy example. It's a tricky one, but we have all the knowledge we need to be able to solve the challenge. In this example, we want Tracy to draw a pyramid of squares centered on the bottom of the canvas, where a user gives the number of blocks in the bottom row. Let's do some planning before we head to coding. Our first challenge is determining where Tracy should be positioned in the X direction for each row of blocks. The first thing that is important to know is that each block has sides of length 50. In this situation, the user has chosen 7 blocks to comprise the bottom row. If there are 7 blocks and they are 50 pixels wide, the total width of the row of blocks is 350 pixels. We want to center this row on the bottom of the canvas, so to find the X value, we need half of the blocks to be on the right side of the Y-axis and half to be on the left. If the whole row is 350 pixels, this means that there are 175 pixels on each side of the Y-axis. Now, if instead the user chose 4 blocks for the bottom row, this would mean that there are 4 blocks times 50 pixels, which gives us 200 pixels for the entire row with 100 pixels on each side of the Y-axis. We just need to make sure that we have a variable that records how many blocks are in the bottom row, so we can subtract 1 from that value each time we move up. We can write a standard equation for the x-axis starting point that will be able to be used for any number of blocks. Our equation is number of blocks times block length, which is 50, divided by 2. This entire number must be negative so that Tracy is placed on the left side of the canvas. We then need to determine Tracy's y value as we move up each row. Let's first recall how the y-axis values are distributed. The y-axis starts at 200 at the top of the canvas and gets more negative as it goes down to negative 200 at the bottom of the canvas. Let's write a generic equation that can be used to determine the y value for each row. We need to take the bottom y value, which is negative 200, and add the block height times the number of block rows, because our y value will get more positive as the pyramid grows and we get closer to the top of the canvas. So our bottom y value is negative 200 plus 50 times 0, which means the y value is just negative 200. When we move to the next row, our y value becomes negative 200 plus 50 times 1, which is negative 150. When we move to the next row, our y value becomes negative 200 plus 50 times 2, which is negative 100. Let's put all this together in our code editor. I've taken the equations we determined for x and y positions and entered them into our code where they're being saved as variables. We also need to create a variable called row value so it can be used in our y value equation. Let's set this to 0 because that's how many rows we have to start. Let's start our code by asking the user for the number of blocks on the bottom row. So numBlocks equals int input how many blocks on the bottom row. And I'm going to limit their values to 8 or less so that all of my blocks will fit on my canvas. Let's make sure we use top-down design to tackle this problem in pieces rather than all at once. We first want to use the input from the user to determine Tracy's starting position. Let's write a function. So we'll write def move to row. And I know I'm going to need to use the numBlocks variable to determine my placement, so I'm going to put it in my function as a parameter. Now here's where we want to use my x and y variables, so let's paste those into my function. Then I want to use them, so I'm going to write pen up and set position, x value, y value, and then I'm going to put the pen down. I'll write another function that will draw a row of blocks. So def draw block row, and I'm going to need to use that numBlocks parameter as well. On the bottom row, we want to draw as many squares as the user entered, which is saved in our numBlocks variable. Let's use that value to control a for loop. So for I in range numBlocks. And this is where we want to draw our square. We've written code to draw a square many times, so we know we're going to use for I in range 4, then forward 50, and then left 90. After Tracy draws a square, I want to make sure she finishes at the right side of the square to draw the next one. So let's add in forward 50 outside of my square loop. Let's test just this part of my code by adding a function call. So down below, I'm going to write draw block row numBlocks. Let's see how this works. Great. Now let's put it all together. I know that if there are 4 blocks in the bottom row of my pyramid, there will also be 4 rows because the bottom row will have 4 blocks, the second row will have 3, the third row will have 2, and the top row will have 1. So I'm going to need to use a loop that is controlled by the number of blocks that the user chose. So I'll start with for I in range numBlocks. I'm first going to call my move to row function. And then I want to make sure that once she's there, my row value variable increases by 1. So I'll write row value equals row value plus 1. After this is when I want to call my draw block row function. So I'm going to indent that into my code. And I want to make sure that after she draws this row, my numBlocks variable decreases. So I'm going to write numBlocks equals numBlocks minus 1. Let's see how this works. Awesome. In this lesson, we explored how we can use control structures together in order to create more concise and advanced problems. Use all the information you've learned so far to solve our most difficult Tracy challenges yet.
Okay, so this one is just an example of the block pyramid we all just saw. So it says the speed equals 0 and the row value is 0. And remember, it's to start off. And they used a function of the blocks, which is one of their variables, and they also put another variable called x value and y value, and soon they put the set position to the x value and y value. The x value is num blocks times 50 divided by 2, and the y value is negative 200 plus 50 times the row value. And then they do pen up, and after they do the set position to the x value and y value and pen down. They did another function for the draw block row, which is the variable in the num blocks, and they did a for loop for I in range num blocks, for I in range 4 and forward for 50 and left to 90 and forward 50, and that one is for the squares. And then they put the input, the user input for num blocks equals int, which I think it's integer, which you're supposed to put in the input, and it asks you the question, how many blocks on the bottom row, 8 or less, and then the parameter, and then closed off by the brackets.
Yeah. The int actually converts what you type into an integer. Okay.
And then there's another for loop for I in range num blocks, the variable, and move to row num blocks, and row value equal row value plus 1. So all of this is basically making sure everything is going up by what is supposed to go up. Like if there's 3 on the bottom, 3 squares at the bottom, like if I run code right now, if I do 3, it's going to do 3, 2 in the middle and 1 at the top. Okay, so this is my code for the guess number 2.0. So what the assignment is okay, so enhance your guess a number program to tell the user if their guess is high or low. Follow these guidelines. Ask the user for a number between 1 to 10. If they did not guess the secret number, the user will be shown an arrow, an up arrow if the secret number is higher than their guess, a down arrow if the secret number is lower than their guess. And when they guess the secret number, a check mark will appear, and the user will stop being asked to guess. And the hint, start with the guess a number program you already wrote and add an if else or elif, which is else if, statement. And this is what the ending word should be when you get it right. So what I did I basically put the question here with the user and the int with the input as well. And I put the question in this here, and you need to remember to put the 2 brackets at the end, because there's 1 bracket here, 1 bracket here, and 2 brackets there for the 2 opens and 2 closes. And I did the secret no is 6, so secret number is 6. I set the speed to 0 so it could go faster when I run the code. And then my first if statement, if secret number is greater than the user input, so if it's like 5, that means it will have to do a down arrow. So if I do 5 right here, it will do a down arrow, and I cleared it afterwards. And the else if the secret number is less than the user, so if it's 8, that means it's going to do it says it's greater than what it's supposed to be. And if I did else, so the secret number is 6, so that means if I do else, it's probably going to mean 6, and it this is all the code to do the tick. So when I put it there, 6, it does the tick.
Okay, cool. Thank you, David. So I think that takes us to the next one. Let's submit that. So we're going to do the rest in the breakout room. Okay. So any question before you guys go to the breakout room? So you need to do this one in the breakout room. Okay. Circle pyramid 2.0. Okay. So before we do that, I need some guys that want to lead the group. So your task is to ensure that your team is able to do this together. Okay. So you should raise your hand up if you want to lead the room. So one thing I want to
raise my hand. Can
Do you have to be?
Yeah, you can type if. Sorry.
You have to be finished for the one we're
Yeah,
doing.
I will prefer everyone is able to finish because we have almost like yeah, let's say half an hour to do this. Okay. So I want to see who is able to finish, okay, in the team. Okay. So you guys need to ensure that you are able to help your team member to finish. If you finish, okay, you should go to lesson 5, okay, and do the exercise on lesson 5 on unit 5. Okay. So any question before we go? So if you raise your hand, you're going to be one of the leads. So I think there might be more than one leads in the team, so you should participate together.
I think some of you have already raised your hand, so if you don't want to be the leader of the group, you can just raise it.